Get into it. Okay. So for the first two guys, I'm gonna re-explain real quick. We multiplied 6 times 4, giving us 24. The exponents here are two invisible ones, so 1 plus 1 gives us the 2, so 24x squared for number 1. Number 2, we multiplied the -7 and 0.2, which gave us the -1.4. And then we're adding the two exponents 2 and 5, giving us 7, -1.4x to the 7th power. Now for the final problem, -1/3 x to the 5th, -2/9 x. So we're gonna multiply the two fractions, right? So we're gonna get equals negative. Sorry if you guys hear kids in the background. My sister brought her kids over and they're hanging out. So my apologies if they leak into the audio. So it'll be -1/3 times -2/9. And it's gonna be x. What are my two exponents I'm gonna be adding for number 3? Anyone want to take a guess? It'll be 5 plus 1. So let's go ahead and multiply the two fractions across, right? -1 times -2. -1 times -2 is a +2. And then 3 times 9 is 27. And then x to the 6. And we can't simplify anymore, so we are done. What questions do we have, if any, for examples 1, 2, and 3? It's just adding the laws of exponents. We're remembering what to do when multiplying fractions, multiplying decimals. Nothing new here, okay? Let's go ahead and try and see what the next slide is. Move on. We have our first practice problems. I'm going to give you guys about 2 minutes on these, and I'll add an extra more time if y'all need it. Good luck. 2 minutes. I'm gonna do 3 minutes, so y'all have time to write these down as well. 3 minutes. Good luck. Alright, that was 3 minutes. Anyone needs more time before we move on? Before we talk about the answers? Last call for more time. Alright, go ahead and share your answers for number one in the chat. Alright. Excellent, Tanya. Good job, Joshua. Excellent, Riley. Excellent, Priscilla. Excellent, Brianna. Nice. Good job on multiplying the constants, guys. Adding the exponents. Good. Anyone have any questions on number one, right? I'm gonna write the answers since people don't see the chat on the video. So for number one, we got 10y squared, which is correct. Good job, everyone. Anyone need me to explain how we got it? All right, guys, go ahead and tackle numbers. Go ahead and share with us number two. What did y'all get for number two? Excellent. So far, we have -2z to the 8 for number two. If you got -2z to the 8, guys, you are correct again. Good job, class. Anyone have any questions how we did number two for the practice problem? Any questions at all? All right, if there's no questions, go ahead and look at number three. Put your answers for number three in the chat, please. So your numerator, Joshua, is correct, but double check your denominator, sir. Yeah, no, and if you and even if you got it right on the paper too, always double check what you type into the computer, whether it be on the chat or on the My Math Lab, right? Because I actually had a student who came in to work on the assignments, and she was doing one of the tests, and she had all the answers right in her notebook from working it out by hand. But when she plugged them into the computer, she forgot a negative sign. She forgot to put the exponent. It was a lot of little tiny things, and she was so mad at herself. And I told her, well, luckily, like, you can try again, but this time double check. Always make sure that everything matches up. So if you guys got 7/72 b to the 9th, you are correct. Good job, class. Any questions on these three practice problems before we move on? Any questions at all?
Yes, I have a question. So all we're doing is multiplying the coefficients and adding the exponents?
Excellent. That is correct. That is true.
Okay, thank you.
All right, moving on. Kayla, happy birthday. Thank you for showing up on your birthday, dude. I hope this is a good lesson for you to get through and you're able to learn some math today on your special day and that you're able to spend some time for yourself later on. Um, yes, and if you're not in the comfortable space to do your notes today, I will be sending out the video today or tomorrow. So no pressures, but I do appreciate you logging on, Kayla. I really do.
Thank you so much.
Yeah, I'm a summer baby too, so a lot of us don't get a lot of love because we're in the summer, but it's okay. I respect it. All right, guys. So example A. Use the distributive property to find each product. We have 5x parentheses 2x cubed plus 6. Can anyone remind me what property we'd be using to multiply this 5x to the polynomial on the inside? It starts with the letter D.
Distributive.
Yes, distributive. Hashtag nerds, that is. We're going to distribute that 5x to everything inside the parentheses. Luckily, we know how to multiply coefficients and we know what to do when we have the variable. Don't forget the invisible one there. 5 times 2 is 10. And we're adding the 1 and 3, which is 4. Now we're going to go ahead and multiply 5x times 6, which is just a 30x. No other exponents added, so we just keep the x there. And question, guys, before I box, can I combine these two numbers? Are these like terms, yes or no?
No.
No, thank you, thank you. Now, remember all the questions I'm asking you during the note, like, hey, can I combine these? Hey, what exponents there? These are questions of the things that I want you and you to think about as we work through the lessons, as you work on your assignments, as you do math, is can you pick up these things later on without me asking you? Right? That means growth, right? Are you growing as a student? Are you growing as a mathematician? Let's look at B now. We're gonna go ahead and distribute. Now in this case here, we're gonna happen to distribute it 3 times, right? Because we have 3 terms here. So now let's go multiply, right? -3 times 5 is a -15. So -15, and then we're adding the 2 and 2, which is 4. And then we do -3 times +6, that's a -18 again, right? And then we have x squared and x, that's a 2 plus 1, which is 3. And then last but not least, a -3 times a -1, 2 negatives makes a positive. 3 times 1 is 3, and then bring the x squared with it. Look at all of our exponents. Do we have any like terms? They're all different, so we are done. Does anyone have any questions on the steps we took for these examples? The distribution, the multiplying, the coefficients, the adding the exponents. Any questions at all? All right, does anyone need extra time to copy this slide down before we move on to the next slide? All right, let's move on. Here is your next set of practice problems, guys. Next set of practice problems. I'm gonna go ahead and give you guys about 2 minutes on this one. I'll add more time if needed. I'll see you guys in 2 minutes. All right, everyone. So anyone need more time to work these out, or was 3 minutes decent for these two examples? Be honest. All right, Brianna, would you like 1 minute, 2 minutes? All right, I'm gonna go ahead and add 1 more minute and then we'll go ahead and talk about it, okay? All right, guys, that was the additional minute. Let's go ahead and share our answers on our chat for letter A. What did y'all get for letter A once y'all distributed the 3x? We have 27x to the 6 plus 33x. Sorry, I didn't know I was still muted. All right, we have 27x to the 6 plus 33x. 9 times 3 is 27. The 1 and the 5 is 6. 11 times 3 is 33. We are correct. Good job, everyone. Thank you guys for chiming in. Let's see what you do. How'd y'all do for B? B is the trickier one, so good luck. How'd y'all everyone do? Go ahead and type in your answer now. I know it'll take a minute, so just take your time writing, typing it out. This is we're sharing our answers for B now. No worries on how long it's taking, guys, just as long as you're putting in the effort too. I would appreciate it. This is what I'm seeing from a lot of people. Negative 12x to the 5th plus 54x to the 4th minus 12x cubed. Priscilla, was that first exponent? Yeah, there you go. I figured it was a mistake, a typo. Okay, okay. Giving it a few more minutes, a few more seconds to see if anyone else is sharing their answer. Excellent, excellent, Nicholas. Good, good, good. All right, is there anyone still typing in their answers before I move on? So if you got negative 12x to the fifth plus 54x to the fourth minus 12x cubed, you are correct. So far, multiplying is not too bad, right? All right, does anyone have any questions so far regarding using the distribution property? All right, let's go ahead and move on. Now, the next example, we're multiplying 3x plus 2 times 2x minus 5. I'll give you about a few seconds to write this down before I jump into it. All right, so let's go ahead and learn how to do this one. So how do we multiply this, right? So this method's called either double distribution or FOIL. So what we do is we draw arrows. So the first arrow we draw is from 3x. And we're gonna multiply that to the 2x. So that's the first arrow. And we're gonna multiply that out first. 3x times 2x is 6x squared. Now, I'm gonna draw an arrow from the 3x to the -5 now. We're multiplying the first term, 3x, to each term on the right parentheses, right? So it's gonna be 3x times -5, which is -15x. Next, what we're gonna do now is we're gonna multiply the second term from the first parentheses to the first one here. So noticing how everything gets multiplied with each other, right? So it's gonna be 2 times 2x, which is 4x. And then we finish off this process by multiplying this +2 with this -5, making it -10. Now that we multiplied the first term with each term in the second parentheses, we're good. And we did the second term times each in the second parentheses. We have them all here. We notice that we have some like terms. We can only combine these two in the middle. When we combine those two, the final answer results in, so bring down the 6x squared. -15x plus 4x is -11x minus 10. And since there's no more like terms, we're done. But notice after I drew one arrow, I multiplied immediately after the first arrow. Please, please do not draw all 4 arrows and then multiply, because you're gonna draw the 4 arrows, be like, which ones are for this again? And it causes a lot of questions, and it questions you and your confidence. Notice how I did each arrow and then I multiplied after I drew the arrow. I want you to try that out as well. Anyone have any questions on the steps here for multiplying these polynomials? All right, if there's no questions, guys, here is your practice problem. I'm gonna go ahead and give you guys 2 minutes on this one. Good luck. All right, guys, was 2 minutes enough for you to multiply and combine? Or does anyone need more time? Last call for more time. All right, go ahead and share your answers for the multiplying these two polynomials, guys. What did y'all get? And I want the final product, okay, after you combine the like terms. Excellent work, Priscilla, Antonio. So I'm seeing 10x squared plus 11x minus 6. Did you guys use the arrow technique? Did the arrow technique make sense to you guys as you worked it out on your own? Or were you able to freehand it without any arrows? You just kind of knew what to do. How does everyone feel about this example? Excellent. Good. Yeah, one of my experiences as a teacher and professor is I notice when students do not use arrows to multiply distribution or polynomials, they tend to make more mistakes than the students who had the arrows. All right, good job, everyone. So if you got 10x plus 11x minus 6, you are correct. Anyone need me to work this one out before we move on, guys? Anyone have any questions about it? And thank you for the feedback, Brianna. I'm glad the arrows make sense. All right, let's go ahead and move on, guys. Now we have multiplied 2x minus y parentheses squared. I'll give you a moment to write that down. Alright, for this one, guys, we're gonna be multiplying 2x minus y times another 2x minus y. Cause you know how it's squared? That squared means it's being multiplied to itself twice, which is why it's there twice. Now we're gonna do the same logic and multiply with the arrows using the arrow logic. 2x times 2x, that's 4x squared. Now we're gonna do 2x times minus y, we're just multiplying. So 2 times an invisible -1 is a -2. X times y is just xy. Now I'm gonna do here, the bottom arrow, -y times 2x. That's gonna be -2yx. And then -y times -y, two negatives makes a positive. Y times y is y squared. Now, real quick question, guys, quick question. Do y'all think 2xy is the same thing as 2yx? Yes or no? Do y'all think they're the same thing? Yes or no? What's your thoughts about this before I tell you what's going on?
Yes.
Yeah, they're the same thing. Can anyone tell me why they mean the same thing? Like what justifies your reasoning of why they are the same? And it has to do with multiplication. That's my tip. The reasoning why these two are equal is because they're the same thing. They have the order of multiplication doesn't matter, right? Like for example, 2 times 3 times 4, that's 6 times 4 is 24, is the same thing as 2 times 4 times 3, which is still 24. So, and if this was x and y, right? And this was y and x. So therefore, the order of multiplication does not matter. So we know these are the same thing. So therefore, we combine these like terms. So then we get 4x squared minus 4xy plus y squared. Now, I like to put them in alphabetical order with the xy. So that's why I put -4xy. Any questions on having a second letter like x and y? Any questions on this example? Does anyone have any more questions before we move on? All right, here is your practice problem, guys. Good luck. I'm gonna go ahead and give you guys, do I think 2 or 3 minutes would suffice for this one? 2 or 3? Put it in the chat. What do you think? 2 or 3 minutes for this exam, for this practice problem? All right, I'm gonna go ahead and give out 2 minutes. Good luck. All right, guys, that was 2 minutes. Anyone need more time before we share our answers from the chat? Last call for more time. All right, go ahead and share your answers for this practice problem. So for this one, we'll be multiplying 5x minus 3y times another 5x minus 3y. So what did y'all get when you multiplied those two? I'm seeing 25x squared, between minus 30xy plus 9y squared. Interesting. Twenty-five x squared minus 30xy plus 9y squared. If you got this, you are correct. I'm sorry, I don't mean to scare you or leave you thinking that you're failing, but you got it. If you got 25x squared minus 30xy plus 9y squared, you are correct. Now, make sure you guys are doing your steps, understanding the multiplication, adding the exponents, and combining your like terms. Are there any questions so far on this practice problem? Anyone need me to work it out more, or other than just what I've done so far? Any other comments or concerns? All right. Let me go ahead. All right. If there's no questions left, guys, let's go ahead and move on. The plot thickens, everyone. We have t plus 2 times 3t squared minus 4t plus 2. Now the plot thickens. We have a trinomial times a binomial. Give you a few seconds to set that up. All right. Let's go ahead and set it up, right? So the way you will set it up is very simple. So it's gonna be t plus 2 times another 3t squared minus 4t plus 2. Now, I know I showed you the method with the arrows. Yes, we can do the arrows for this one. Like for the first term here, the T, we will just draw 3 arrows going to all the right one. And then we'll draw 3 arrows for the bottom 2. But I would like to show you a other technique that's different from the arrows. All right, so the biggest thing here, so the next method I'm showing you is box. Now, if you are content with the arrows and you know you will not make a mistake with the arrows, you go ahead and do the arrows. If you are down to try another method with me, and that way you have 2 methods under your belt, whether it be the arrows or the box method, you can use either one when multiplying polynomials. So for the box method, you guys see there's 2 terms here, 1, 2, and then there's 3 here. So we're gonna have to create a 3x2 box. So watch me create a 3x2 box. Make sure it's big enough for you to fit a number and letter inside of the box. So then on the side here, so there's 2 terms here, this is gonna be a T, this is gonna be a +2, right? Because that's what's inside this first parentheses. The second parentheses is a 3t squared. Then we have a -4t. And then we have a +2 here. And here we are, we have the setup. Now, I want you to treat this box method here as a multiplication table. A multiplication table. So what that means is we're gonna multiply these 2 for this box here. And then so forth. So the row and column have to match, okay? That is the goal here. So for this first box, we're gonna multiply 3 times the 1 here in this T. 3 times 1 is 3. And then T to the 1 power times T squared, we have to have the exponent, which is a 3. 1 + 2 is 3. And that's what fits in that box. Now let's do the second box over here. 1t1 to -4t1. Well, we know 1 times -4 is -4. 1 + 1 is t squared. And then last but not least, 1t1 times 2 is just 2t1. Or just 2t. We don't have to draw the 1. That was the first row. Now we're gonna fill out the second row. 2 times 3t squared is pretty much 6t squared. Positive t, 6t squared. Because 2 times 3 is 6. 2 times -4t is -8t. 2 times +2 times, we're multiplying, remember, is a +4. And now that we have it all multiplied out, we write equals to, and then we bring down everything else. We bring everything inside 3t cubed. Now I'm gonna keep the exponents, the like terms together. These are like terms and these are like terms. So then it'll be +6t squared -4t squared -8t + 2t + 4. Now, the beautiful thing is we have these like terms here, and we have these like terms here. So 6 take away 4, so I'm gonna bring down the 3t cubed. 6 minus 4 is a +2t squared. -8 + 2 is -6t. And then bring down the +4. And we are done. Has anyone ever heard or seen the box method before? Or was this y'all's first time seeing this method in the math lesson? Let me know your thoughts in the chat. First time, Brianna, interesting. Tell me your thoughts. First time, Priscilla, too. So what y'all think? Did y'all think the arrows are much better for you or nicer? Or do you think this box is more organized for you as well? I'm gonna be honest, box method is my choice, my method of choice. You're probably wondering, well, why didn't show us the first one? Well, I feel like sometimes there's a need for it. Like for the first couple ones, the arrows did fine because there's only like 4 arrows in total and it's like distribution. Whereas this one, that's 6 arrows we would have drawn. And I've noticed the more arrows we tend to put in our notes, the more confusion some students have gotten. But for me, box method, like it organizes the result. You can see what's gonna be combined. You can see the like terms in the box. So when you write it out in the line, it's much smoother. But you know, it doesn't matter, you know. So this is box method, okay? Any questions on the problem here? Any questions on the procedure or steps that I took? So crazy that it's y'all's first time. It blows my mind. All right. You're ready to try a practice problem similar to this? Now, do you have to do the box method? No, you don't. Is it encouraged? Yes. There you go. See, you feel me, right, Brianna? Like the other ones are much smaller, so that there's not enough arrows. But this one gets more little intense because it's bigger. So yes, okay, cool. I'm glad you see my reasoning behind when to use the different methods. Okay, so I challenge all of you, try the box, set it up yourself. It's a 3x2 again. I'll set it up, and then your job is just to multiply it out and combine like terms. I'm gonna give you guys, since it's a juicy one, I'm gonna give you about 3 minutes on this one. Hopefully that's enough time to multiply and combine like terms. All right, 3 minutes. All right, guys, was 3 minutes enough to handle this practice problem, guys? Anyone need more time before we share the answer? All right, go ahead and share your answers then on the chat. What did y'all get? Double check your symbols and exponents before you submit. So for the final answer, we got 2y cubed plus 5y squared minus 7y plus 20. If you got 2y cubed plus 5y squared minus 7y plus 20, you are correct, guys. Good job. Any questions here on the algebra, the steps that we took? Did anyone successfully use the box method on their own? Or did y'all do the arrows? No pressure, right? On which one's better over the other. Excellent, Tanya. Excellent, excellent. Nice, and it still worked out for you. Good, Priscilla. Good, good, good. All right, all right. Any questions so far in this one? Okay, let's go ahead and move on. Now we're multiplying 3a plus b cubed. So that's pretty much, we're gonna be multiplying 3a plus b times another 3a plus b times another 3a plus b, because it's cubed. So for the first two, we're just gonna use arrows. So 3a times 3a is 9a squared. 3a times b is a plus 3ab. B times 3a is another 3ab. And then the last one, b times b, which is b squared. So now, do we have any like terms here? Yes, we do. We have the 3ab's. So then we get 9a squared plus 6ab plus b squared. In parentheses, because that only gives us these two, we still need to multiply this third one here, 3a plus b. Now you can continue to use arrows for this next multiplication problem, but since I showed you the box method, I'm gonna go ahead and bring that back in here. So draw a box, it's gonna be a 3x2. So it'll be 3a plus b here, and then this is gonna be 9a squared, 6ab, and b squared. Alright. Let's go ahead and multiply together. 3 times 9 is 27. A times a squared is a cube. 3a times 6ab, so 3 times 6 is positive 18. A times a is a squared, and we still have one b there, so bring it there. And it's gonna be 3a times b squared, so this is gonna be 3a b squared. Just multiply those two together next to each other. Then b times 9a squared will be plus 9a squared b, right? The b just goes added on there. B times 6ab is gonna be positive 6ab squared. Because b and b is 1 and 1, so squared. Then b times b squared is just b cubed. Now write it all down. Notice how the diagonals, these are both like terms here. So then it'll be equal to 27a cubed plus 18a squared b plus 9a squared b plus 6ab squared plus 3ab squared plus b cubed. These are like terms and these are like terms. So 18 plus 9 is 27a squared b. And then 6 plus 3 is 9ab squared plus b cubed. No more like terms, and we are done. Look at quite the beast we just encountered. Any questions, comments, or concerns regarding any of the steps of multiplying this polynomial? It's a little tricky, I know, because we're multiplying multiple letters and numbers, right? But as long as you draw your arrows and understand what's multiplying, you're multiplying the coefficients, adding your proper exponents, right? You don't add an exponent to a if you're multiplying a b, right? And then we combine our like terms and finish off the problem. Anyone need more time to write this before we move on to the practice problem? All right, if no one needs more time, guys, here is the next slide. Multiplying s plus 2t cubed. I'm gonna go ahead and give you 4 minutes on this bad boy. Good luck. All right, guys, was 4 minutes enough for you guys to tackle this beast of a practice problem? Was 4 minutes enough? Or does anyone need more time? All right, let's go ahead and share your answers then. Let's see how you guys did. All right, the answer I got in is S cube plus 6s squared t plus 12st plus 8t cube. If you got s cubed plus 6s squared t plus 12st squared, right here is t squared plus 8t cubed. You have those four terms in your final answer. You are correct. Tanya, I'm not too sure if the last exponent was a typo, a 2, or if you forgot to add the exponents when you multiplied t squared and t at the end. Does anyone have any questions regarding this practice problem, guys? All right. If there's no questions, let's go ahead and move on, guys. Good job. Thank you, Tanya and Adam, for contributing, guys. Any other questions, guys, from anyone before we move on? All right. We did it, guys. We just finished our first lesson out of the 2 from today. We are on the second one. Let's go ahead and do a 5-minute breather, a break, and we'll jump onto it after the 5-minute break, okay? I'll see you guys in 5 minutes. If you don't want to get water, stretch your legs, go ahead and start this slide if you want to. I'll give more time when we get back. See you in a bit. All right, guys. Anyone need more time on this slide writing the FOIL method? So once again, type it in the chat, we need more time. So the FOIL stands for F is the first terms, which is the first arrow, 3x times 2x, which is 6x squared. O stands for the outside terms, which is the 3x and 5, which is 3x times 5, which is 15x, which is the O. I stands for the inner terms, which is 1 times 2x, which is just 2x itself. And then L stands for the product of the last terms, 1 times 5, which is still 5. Write them all out next to each other, combine the like terms, the 15x and 2x. And here we are with the final answer. All right, let's go ahead and move on, guys. Since you already know the FOIL, go ahead and work this one out. I'll go ahead and give you guys 2 minutes. Same thing, it's pretty much the same concept we learned last lesson with the arrows, but now the arrows have a term, you know. All right, so the first arrow is x times x, right? X squared. And then it'd be x times 4, which is 4x for the outside terms, right? This is the F, this is the O. And then these arrows here is the I, the negative 3x. And then this arrow here is the L, which is negative 12. Combine our like terms, and then we get x squared plus x minus 12. And we are done. Any questions so far in this example, guys? All right, here is your practice problem, guys. X plus 2 times x minus 5. I'll give you 2 minutes on this one again. Good luck. All right, let me know when you're good to go, Josh. My bad. Alright, guys, I'm gonna go ahead and add the timer again. I'm gonna only make it for 1 minute this time. Alright, go ahead and share what you got for the answer for this practice problem, guys, in the chat. So we see x squared minus 3x minus 10. So we'll multiply the x with the x for x squared. Minus 5 for minus 5x, then the plus 2x. And then the minus 10, guys, good job. If you got x squared minus 3x minus 10, you are correct. Does anyone have any questions, guys, on this method? All right, anyone need more time to copy this slide down before we move on? All right. Another example FOIL method, guys, go ahead. Give you about a few seconds to write this example down before I start working it out. All right, so then we draw the arrow first, right, from 5x to x gives us 5x squared. 5x times minus 2, which is negative 10x. Negative 7 times x, which is negative 7x. Negative 7 times negative 2, which is positive 14. Add these two like terms, we get 5x squared minus 17x plus 14. And we are done. Any questions, guys, on this example? All right, let's go ahead and keep going. Here's your next practice problem, guys. Or was anyone still copying this before I move on, guys? Last call for more copying before I move on. Alright, here's 2 minutes for this practice problem, guys. Good luck. Alright, that was the 2 minute timer, guys. Anyone still working on this problem? Go ahead and share your result on the chat, please. What did y'all get for this practice problem? 4x minus 9 times x minus 1. I'm seeing 4x squared minus 13x plus 9. Interesting. Very interesting. So if you got 4x squared minus 13x plus 9, you are correct. Anyone have any questions on how to get this answer, guys? On any of the steps? All right. All right, all right. Here's the next example, guys. Multiply 2 parentheses y plus 6 parentheses 2y minus 1. Alright, so set it up in your notebook before I jump into it. Alright, now this is where it gets tricky and not really tricky, but I don't want you to get tricked by this. This too, it is distribution, but you only distribute it to one parentheses, only one, not both. Only once. Now there is another number here too, like a 2 here, then you would distribute this 2 for this parentheses. But remember, all of these things are being multiplied here. So as long as the 2 goes to one of the parentheses, you're good to go. So now let's go ahead and distribute that 2, right? 2 times y is 2y. And then we have 2 times 6, which is 12. So we have 2y plus 12. Notice how I kept the parentheses because I'm gonna have to multiply it with the other parentheses next to it too. So now we know how to multiply those parentheses because it's like FOIL. So, or like the arrow, so it'll be 2y times 2y, which is 4y squared. 2y times minus 1, which is minus 2y. Then it's 12 times 2y, which is 24y. And then it's 12 times minus 1, which is negative 12. Combine our like terms here, negative 2 plus 24. So bring down 4y squared. You have 24 minus 2, which is still 22 left. And then bring down the minus 12 and you're done. Oh, I'm missing the y here. And we're done. Now, another thing you could have done, right? Let's say you didn't want to distribute the 2, right? What if you don't want to distribute the 2? Then you could have, so you have this, right? Y plus 6, 2y minus 1. So we could have multiplied these two first using FOIL. And after we've done that, then distribute the 2 to everything else, right? The 2. But it doesn't matter. Like I said, like as long as we're comfortable with the steps and the math, like we're okay. Anyone have any questions on this example, guys? All right, here is your practice problem. Go ahead and give you guys 2 minutes on this bad boy. Good luck. Or before I move on, is anyone still copying this before I move on? Sorry. Last call for more copying. All right. Here is the practice problem for 2 minutes. All right, that was the 2-minute timer, guys. Anyone still working on this example before we share our answers? Anyone still trying to work this out? All right, I'm gonna go ahead and add an extra 1 minute or 2 minutes, Brianna. All right, adding 1 more minute. Let's go ahead and share our answers in the chat, guys. What did y'all get for this one? If you got 9x squared plus 42x minus 15, you guys are correct. Good job on only multiplying the 3 to 1 parentheses, not to both. Don't make that mistake. Are there any questions on what we did here, guys? Any questions at all? All right, let's go ahead and move on. We're multiplying 3y plus 1 squared. Which is 3y plus 1 times 3y plus 1. Multiply these out. 3y times 3y is 9y squared. 3y times 1, which is 3y. 1 times 3y, which is another 3y. Ending with 1 times 1, which is 1. Combine our like terms, so then we get 9y squared plus 6y plus 1. And we're done. You can see that this lesson has a lot of emphasis on multiplication, right? You know, we're multiplying coefficients, variables, adding exponents, combining like terms. We're kind of pretty much like combining all the different things we've learned in this class. Anyone need more time to copy this example down before we move on? All right, let's go to move on to the next slide. I'm gonna go ahead and give you guys 2 minutes on this slide. Good luck. All right, that was 2 minutes, guys. Anyone still need more time to multiply this out before we start sharing answers, guys? Anyone need more time? All right, let's go ahead and share what you got for this example, guys. 4x minus 1 squared, which is the same thing as doing 4x minus 1 times another 4x minus 1. What did you get when you multiply this out, guys? I'm seeing 16x squared minus 8x plus 1. If you got 16x squared minus 8x plus 1, you are correct. Are there any questions so far on what we did on this practice problem, guys? Any questions at all? All right, let's go and move on. So here we're learning about different properties here. We're learning about squaring a binomial. So when we have, so we just did it where we did the FOIL, but there's actually a trick to it, a formula really. A binomial squared is equal to the square of the first term plus or minus twice the product of both terms plus the square of the second term. So a plus b squared is equal to a squared plus 2ab. So whatever a and b is, we multiply them by 2, and that's the middle term, and then b squared. So whatever this is squared. Now a and b can be replaced by numbers, by letters, by numbers and letters, and we can plug it into these formulas, guys. So I'm going to give you guys about 3 minutes to set this up into your notebook, and then I'm gonna jump on to these examples, okay? And you're gonna see me apply the formulas. The formulas. The goal of this lesson is to apply the special products that I'm teaching you. So, and I'm gonna start a timer and then give you time to write. All right. So keep in mind, ladies and gentlemen, that we do not have to use these formulas when you're doing your assignments or your homework or your tests. No, I'm not gonna ask you hey, plug it into the binomials. No, it is an additional skill set that I am exposing you to. Now, if you'd like to practice this and use this, I commend that and I prefer that. But in no way, shape, or form am I gonna force you to use this special product in the future, you know? But it is a cool trick to know, actually. It kind of helps you do mental math on multiplying this out without having to FOIL or box method it at all. So t plus 2 squared, ready? So I'm not going to use FOIL, no arrows. I'm not going to write it. Just leave it like this. So equals. So I'm going to put A on top of the letter T and B on top of the 2. So it's like A plus B, but instead of that is T plus 2. So then it's gonna equal to a squared, but instead of a, we know a is t, so that's gonna be t squared. This is a squared. And it's gonna be plus 2 parentheses, and I'm gonna multiply, because I'm multiplying 2 times a times b. Well, I know a is t, so I'm gonna plug in t for a, and times b was 2, so another parentheses 2, and then I'm gonna close that off, plus b squared, which is just 2 squared. Well, let's clean this up. 2 times t times 2 is just 4t. So equals t squared, bring that down. 2 times t is 2t, 2t times 2 is 4t. And then 2 squared is just 4. And we're done. No FOIL, no box method. We just use the formula. Alright, let's look at B. I'm gonna switch my color up. So I'm gonna label A and B. And it's P minus Q squared. So we're looking at this, the bottom equation here, the A minus B squared. So it's equal to. So P, remember it's A squared first, so A is P, so that's P squared. Minus 2 parentheses, A was P, parentheses, B was Q, plus B squared, which is Q squared. Now, minus 2 times P times Q, that just becomes P squared minus 2PQ. We just get rid of the parentheses pretty much. Because we know when letters are next to each other, they're just being multiplied. Any questions so far on A or B? All right, let's take a look at C. So I'm gonna label A and B. And it's A plus B, right? So the top one. So isn't it equal to, I'm gonna switch my color up, right? So this was A and B. So then it's equal to A squared. Ah, but A isn't just a letter anymore. It's a number and a letter. So it's gonna be parentheses 2x squared plus 2 parentheses. A is 2x and then B is 5 plus B squared, which is 5, which is 5 squared. Now 2x squared. 2x squared, guys, is just 2x times 2x. Because it's being squared, right? 2x times 2x is 4x squared. On the middle, we have 2 times 2x, which is 4x. 4x times 5 is 20x. And then 5 times 5 is 25 for 5 squared. And we're done. Anyone have any questions on what I did with the A squared? All right, we're on D, last but not least. So A is x squared and B is 7y. So it's equal to, right? We're doing the second equation, A squared. So it's gonna be x squared squared. Power to a power, that's power rule. So then it's gonna be minus 2 parentheses, x squared parentheses 7y. And it's gonna be plus parentheses 7y squared. Well, for the first parentheses, it's a power to a power, that's power rule. We multiplied the exponent. 2 times 2 is 4. So the first thing is x to the 4th power. Now, all we're doing, guys, is we're plugging it into these formulas right here. That's what it is. So this is A minus 2AB plus B squared. We're plugging it in using the A and B here. So for the middle term, negative 2 times x squared times 7y. Well, negative 2 times 7, that's negative 14. Bring down the x squared and the y. And then last but not least, 7y squared. 7y squared is pretty much with the parentheses in the right here. It's pretty much 7y times 7y, which is 49y squared. And we're done. What questions do you guys have for this lesson? I know this formula seems tricky, but it really isn't. You gotta know that whatever's in front of the minus sign, that's gonna be A. Whatever's after the minus sign is gonna be B. And so forth over here, A, B. And you just plug it into the formula, AB, B squared. Anyone need more time to write this slide down? Last call. All right, moving on. It wants us to use the special product to square these binomials. All right, guys, I'm gonna go ahead and give you guys about 4 minutes on this one. Good luck. Alright. How's everyone doing so far, guys? That's 4 minutes. Anyone still working on these? Remember, they're very similar to the examples I did in class just now, just different letters and numbers, so, but similar concepts. Anyone need more time to work these out? Are you guys ready to discuss the answers? Now, could you do the two parentheses and do your arrows? Yeah, you can, but that's not what this practice is about. The practice is about actually trying the formula out. So last call for more time before we start discussing answers, guys. Last call for more time. All right, let's see how you guys did. What'd y'all get for A, guys? Go ahead and share your answers for A in the chat, please. So for A, we got B squared plus 6B plus 9, which is A squared, right? Times 2AB, which is 2 times 3 times B, which is 6B, B squared, 3 squared, which is 9. That is correct, everyone. Good job, good job. All right, let's see how you guys did for B. What was the final verdict for B? X minus Y squared. So we have x squared minus 2xy plus y squared. Now, keep in mind for A minus B squared is plus B squared, right? Whatever, the minus only goes right here with the negative 2AB. So we have x squared minus 2xy plus y squared. You are correct. Good, good, good. All right, let's go ahead and look at C. C is 3y plus 2 squared. Times we have 9y squared plus 12y plus 4. Anyone else trying to type their answers for C? Anyone need help with C, guys? So far, only one person has shared for the answer for C. Thank you for the correction, Tanya. Definitely okay, it happens. All right, we got 9y squared plus 12y plus 4. You are correct. Because when you put parentheses around the 3y squared, that's 3y times 3y, which is 9y squared. Now for D, guys, your final answers for D. Remember, using the formula, not the FOIL. We got a to the 4th power minus 10a squared b plus 25b squared. Excellent. No, great correction, Nicholas. Glad you caught it, sir. Luckily, this isn't my math lab, so I'm not gonna dock points off, but you're on the right track though. Nice, guys. Nice, nice. So these formulas are pretty nifty, right? How they work out. Anyone have any questions about these uh practice problems, guys? All right. Let's move on. There's this notice, this helpful hint. I do want to take care of some confusion here. So I'm gonna go ahead and let you guys write this helpful hint. I'll give you guys about 2 minutes on it to see if that's enough time. And we'll talk about it later. 2 minutes. All right, all right. The reason why I'm including this helpful hint, guys, because a lot of the biggest misconceptions or confusion is when people say a plus b squared, they automatically think the square goes to the a and to the b, and it's a squared plus b squared. But it's not the case. No. If you multiply this out using FOIL, a times a squared, a times b, ab, b times a, BA, B times B, B squared. AB plus BA is 2AB. So you see what I mean? Like, as long as you know how to multiply binomials, you can clearly make this same mistake, okay? That's why I've included it here, this helpful hint. Does anyone need more time to copy this down before we move on to the next slide? All right, let's move on. Now, this is the last trick. The last trick you need to know is when we multiply a plus b, and so pretty much the sum of two numbers and the difference of two numbers, it gives us the a squared minus b squared, like a plus b times a minus b. So a times a will be a squared. A times minus b is minus ab. B times a is ab. And then equals a squared minus b squared. I'm gonna show you to like multiply it out so you know I'm not like crazy. So a times a is a squared. A times minus b is minus ab. B times a is plus ab. B times minus b is minus b squared. Notice this ab's cancel out and we're left with a squared minus b squared. This is called the difference of squares. So this is a trick, another trick we're gonna learn in this class. And this is the last trick of today. The last trick from today, guys. This is the last example, and then we have one more practice slide and we're done with today's lecture, guys. I'm gonna go ahead and give you 3 minutes to write this down and get started on the example, like writing it out, and then I'll start with A shortly. 3 minutes. All right, guys, so let's jump into it. So now we're pretty much gonna take A and B, which you can clearly see, right? Like for A, we have the 4 out here, right? So we have to multiply that 4 eventually, but we're gonna do these two first. So we have the x plus 4 and the x minus 4. So right there, you can clearly see because it's A plus B, A minus B, we can see that this is A and that's B. And remember, the formula is just, we're just gonna square the two and subtract them. So it'll be 4 parentheses A squared, which is x, x times x, which is x squared. And then it'll be minus, right? Because it's minus in the formula, B squared. B is the number 4. 4 squared, 4 times 4 is just 16. And then that's it. We're gonna go ahead and distribute the 4, right? Because it's on the outside, which is 4x squared minus 64. And we're done. We're done with A. So we did the formula and an extra rule, but with distributing the 4. Let's look at B. Oh, B. 6t plus 7, 6t minus 7. So right there, we know 6t is A and B is 7. Y'all can agree with me on that? So remember, we know it's A squared minus B squared, so it'll be parentheses 6t squared minus parentheses 7 squared. A squared minus B squared. Y'all agree with that? So 6t squared is 6t times 6t, which is 36t squared. 7 squared is 7 times 7, which is just 49. And we're done. Let's look at C. C, we have x minus 1/4, x plus 1/4. We have A and B established. So be parentheses x squared minus parentheses 1/4 squared. Now, the beautiful thing about this trick is we've done x squared. That's just x times x, which is just x squared. Then we have minus 1/4 squared. So remember, when we have an exponent with a fraction, we know that 2 is going to go to the top and to the bottom. So it'll be 1 squared over 4 squared. We simplify the fraction, so bring down the x squared. We know 1 times 1 is 1. 4 squared is 4 times 4, which is 16. And we're done. All right, we're on D. So D, we have A and B labeled. So it'll be A squared, it'll be 2p squared parentheses. Notice how the square has to be outside the parentheses, guys, not inside, okay? And it'll be minus q squared. Well, let's simplify that. 2p times 2p is 4p squared. Q times q is just minus q squared. And we're done. E. 3x squared minus 5y, 3x squared plus 5y. It can get pretty ugly, A and B. But luckily, we know the formula, parentheses 3x squared squared minus 5y squared. Well, 3x squared times another 3x squared. That's what this first one is. 3 times 3 is 9. X squared times x squared is x to the 4th. So, and then over here we have 5y times 5y. 5 times 5 is 25. Y times y is y squared. We get minus 25y squared. We're done. Notice there's no arrows. There's no box method necessary. As long as you see that pattern, you can do a plus b, a minus b. We know it's gonna be a squared minus b squared. What questions do we have on this slide? All right, guys. It's 3:18. I am gonna go ahead and stop the recording here.